Last class, we started talking about a new category of hydrocarbons called the alkenes. The alkenes have one or more double bond present in the substance. A question to start you off today. How come there is no such thing as methane? How come there is going to be no such molecule as methane?
Oh, it's about the balance. It's about the balancing of the carbons to hydrogens.
The requirement of an alkene is a double bond. Do you know what? What do you think?
I'm reading the page. It says alkenes contain at least one double carbon bond.
Alkenes must have at least one carbon-to-carbon double bond. How many carbons are there in methane? Oh, one. So meth is one carbon. Is there a second carbon to make a double bond with? No. But the requirement of an alkene is that there is at least one double bond between carbons. So you cannot make an alkene out of methane. You can have methane, an alkene, but you cannot have an alkene with one carbon. So yesterday we started taking a look at alkenes through a video. You have some notes that I gave you. It's a one-page, sheet. Alkenes have one or more double bond, and we can see that it looks like an equal sign somewhere in the model picture. If we have a name, how can we recognize that something is an alkene? If we have a name, how can we recognize ene? Exactly. ENE ending. What about if you have just carbons and hydrogen numbers?
Twice as many hydrogens as carbons.
Yes. Alkenes, you have 2n plus 2. So in alkenes, if I have 8 carbons, I have to have exactly double that number in hydrogens. H16. So the general formula for alkenes is CnH2n. At the end of the class yesterday, you were supposed to be writing that down in your yellow book somewhere so that you knew. And again, if you have a structural molecule, you should see a double bond or an equals between carbon somewhere in that molecule. So let's say we have a molecule such as butene. How many carbons are in a molecule that starts with but? 4. So draw a carbon chain 4 carbons long, please. Draw a carbon chain that is 4 carbons long. If you still want to do Lewis diagrams, you're welcome to. If you want to start working with the ball and stick model, it would look like this, because you know that each carbon is going to be sharing one pair of electrons. Two of those carbon need to share. The requirement of an alkene is that you have one double bond or more electrons being shared between two carbons. For the sake of simplicity, I'm going to put the double bond right here. So if you were drawing the ball and stick model, it would look like this. How many hydrogens would I have to add to the first carbon in order to fulfill the octet rule? 2, because I have one vacant electron here and one vacant electron here. Remember, you have to fulfill the rule of 8. So 2, 4, 6, 8 electrons are being shared, or look for 4 bonds. A line in a ball and stick model equals 2 electrons being shared. So 2, 4, 6, 8. If we look at the second carbon, we're already sharing 2, 4, 6 electrons. How many hydrogen can connect? Only one. We only have one vacant dot up here. There's only one place for hydrogen. You can double check by counting the number of lines. 1, 2, 3, 4 times 2 electrons each is 8 electrons. Then we go to the third carbon. How many hydrogen can we add here? 2. 1 up here, 1 down here, 2, 4, 6, 8 shared electrons. Or again, we can count the lines. 1, 2, 3, 4. How many hydrogen would have to be added to the last 3? You have 3 lone electrons. 1, 2, 3. So in this model, 1, 2, 3. How could you confirm that this model is correct?
Use the formula and then count up how much you have.
Double check your hydrogen at the end of this. If you have something like, 9 hydrogen, that doesn't fit. The number of hydrogen in an alkene has to be exactly double. 1, 2, 3, 4, 5, 6, 7, 8. The other double check is to look for 4 lines or 4 bonds coming from each carbon. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If I had something like this, that's showing 10 electrons being shared. That does not fulfill the octet rule. When you draw alkene structures, my tips are draw the chain first. Put the double bond somewhere, and then add your hydrogen. I find if you make adding the hydrogen your second step, you put way too many on because you forget about the double bond. Make the double bond placement your second step. It is possible to come up with another structure using the same number of carbons and hydrogens. This was the first one. We can change the structure of this by putting the double bond in a different place. Instead of having the double bond between carbon, the first and the second carbon, we could make a different structure which has the double bond between the second and third. That changes the number of hydrogen that can be attached to these three carbon. On the first carbon, we now have to have 3 hydrogen. On the second carbon, you can only have 1 hydrogen attached to it because you already have 2, 4, 6 electrons being shared. On the third carbon, 1, 2, 4, 6 electrons. And then on the last one, we would have something like this. These two molecules both carry the name butene. It is completely unfair for me to say, draw me a molecule of butene and then assess you on that, because there's more than one answer. Chemistry demands specificity. You have to have some way of showing where that double bond is when you name it butene. We use a street address. We use a number to indicate the first carbon that double bond is attached to. When you number a carbon chain, always number it from the side where the double bond is closest to the end. For example, 1, that's carbon number 1, carbon number 2, carbon number 3, and carbon number 4. Carbon number 1, carbon number 2, carbon number 3, carbon number 4. We add that to the name to show where that double bond has to be. Question for you. Why does 3-butene not exist?
Just the opposite of 1 and the molecules rotate.
It's a 180-degree turn of the molecule. I'll draw it out to So if I took this molecule and I turned it 180 degrees, it's still 1-butene. The easiest way to track this is number the carbons. Carbon number 1 is the one that the double bond is closest to. If the molecule is like this, this is not carbon 1. The double bond is closest to this one. So I actually go 1, 2, 3, 4, and this is still 1-butene.
I'm going to draw all my backwards.
Of course you are.
I will make sure to draw carbon.
I wouldn't expect anything less than that. So just some suggestions for naming. Most of these are already down on the first page of that worksheet. Remember that the first part of the word comes from the number of carbons. So you have to count the number of carbons. Always count from the side where the double bond is closest to. You must indicate the street address of that double bond first. Then you're going to place a dash. Then comes the prefix for the total number of carbons. And finally, your ENE ending. Wrong binder.
Considering you'd have to train me, I don't think that's how it works.
The best way to work through this is to practice. In your worksheet bundle that you received on Friday, the last 2 pages of that are a chart that looks very similar to the alkenes chart that we did. It's on page 3 and 4 of that booklet. We are going to, this worksheet is all for alkenes. There's going to be no alkenes on this worksheet at all. So if you have 5 carbons in this molecule, how many hydrogens will you have? 10. It's got to be exactly double. Now notice, I have 2 rows. Why?
Two different drawings, routine 1 and 2.
There's going to be more than one drawing. Pentene has 2 isomers. So for the first 2 rows, they're going to have the same number of hydrogen, 10 each. Both of them are going to have the name pentene. But you're going to have to add a street address for that double bond. So when you write the name pentene, leave a place for putting that number where the double bond is going to go. Is everybody finished with this slide? Okay. I need to pull up a blank one rather than write on the sideboard. Draw your carbon chain first. 5 carbons long, please. If you would rather use your Lewis dot structure, that's fine. What you will find is when we get to longer chains, the Lewis dot structure becomes really messy, and it's hard to keep the electron dots separate. Place your double bond. Personally, I like to work from left to right. James is going to be the rebel, and he's going to work from right to left. No? Okay. So just with my OCD organization tendency, for the first molecule, I'm going to put my double bond on the first carbon. Now add your hydrogen. Remember, you should have 4 lines and only 4 lines coming out of each carbon. So we already have 2 electrons being shared. This carbon can only take 2 hydrogens. 1, 2, 3 shared electron pairs. This one gets 1 hydrogen. 2 shared pairs already. You need 2 more shared pairs to get up to 8. I'm going to number my carbons. I'm going to start carbon number 1 that's closest to that double bond. 1, 2, 3, 4, 5. The lowest numbered carbon is 1 that double bond is attached to. So the proper name for this is 1-pentene, not just pentene. If you forget your street address, the name is incorrect. Then you go on to your second molecule. Draw out your carbon chain first. You need to put the double bond somewhere else. I'm going to put it between carbon number 2 and carbon number 3. Add your hydrogens. Now remember, in organic chemistry, we expect that if there's a dash and there's nothing at the end of that dash, it's automatically hydrogen. So you do not have to put H through all this. It is totally legal to do that. But make sure those lines are clear, because if I don't see 4 lines around carbon, I'm going to bust you. I can't every single one of those lines. Remember, double check carbons. Double check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure that you have the correct number of hydrogens.
This must be the most boring unit to mark.
It is a rather tedious one to mark. It's like marking oxidation numbers. I need a magnifying glass and a cup of wine. I mean,
Just record.
Actually, no, I don't have any wine when I mark.
Disclaimer, only fun.
No,
Only fun.
no alcohol. I have to be nice to my liver because the medications that I take are not nice to my liver. So wine is very spared, especially when you're making a redox test and people have brain farts. Okay, the lowest number that carbon is attached to is number 2. This is 2-pentene. Can we have a 3-pentene?
No.
Because if you take this and rotate it 180, it's still 2-pentene. Same thing with 4. You really, really have to watch for mirror images in chemistry. The longer and more complicated the chain gets, the harder it is to keep track of what's a mirror image. You will need to look at boiling points on your technology. Make sure that when you look at boiling points, you put the address in there. Okay. For hexene, there's 3 different isomers. That's why there's 3 different lines. For heptene, 3 different isomers. And for octene, 4 different isomers. Give it a try.